Okay, welcome to part two of 3.2. Okay, so now what we're going to be doing is the surface area of cones. So last time we were doing pyramids. Now we have a circular bottom, so it's going to be a cone. They're similar. What we're going to do, though, is we're going to break it into two parts. We're going to figure out the surface area of the circle, and then we need to figure out the surface area of the rest of it. We call that the lateral area. So just those two things, right? So first off, we want to figure out the surface area of a circle. That's just, so area is equal to pi r squared. We were using that one, right? And then the area for the lateral part of this, like everything else but the circle, the formula for that's going to be A is equal to pi r s. Now, S you haven't seen before. S is called the slant height. That's going to be the distance just from the bottom of like where the cone starts to the tip there. So that distance from there to there. Okay, so you guys can look through that question, or I guess the next one here. So number 5. I'll jump into a question here. So this one says, find the surface area of a cone that has a slant height of 82 centimeters and a radius of 28. So if we had a cone, terrible cone. Anyway, we'll get the idea across. It has a radius, so the distance from the center to there, of 28. It's got a slant height of 82, so from there to there is 82 centimeters. All right, so now if we actually just put this into our formula here, let's figure out the area of the circle part of it first, so all of that. So we're going to say area is equal to pi r squared. That's the formula for a circle, right? So that's for a circle. And then if we fill this in, the area is going to be equal to pi times, I'm going to change r to 28. That's what the radius was, right? So 28 centimeters, square it. So then if I put that into my calculator, the area of that is 2,463 centimeters squared. How many units? Okay, so what I'm going to do now is just put a box around that so I can remember that for after. Now what I'm going to do is figure out the surface area of the lateral part, so everything else in our cone. I know that cone's kind of looking terrible now. Okay, so the surface area for the lateral part is area is equal to pi r s. So the area is equal to pi, so 3.14, times the radius is still 28 centimeters. And now just times again by the lateral height. So the lateral height is 82 centimeters. So the area there is going to be 7,213.1 centimeters squared. Okay, and then the last thing, we just need to add those together because we want the total. So adding those together, we're going to go area is equal to 2,463 plus 7,213.1 centimeters squared. So the area is equal to 9,676.1 centimeters squared. And that's my answer. All right, 14. Find the surface area of a cone with a diameter of 13.6 and the slant height of this. So that's going to be actually the exact same. Well, not exactly the same, but really close. Oh. Okay, there's my cone. It's going to be really similar, but the only difference here is that it gave us this time diameter, right? Diameter instead of radius. So remember that diameter is just the distance from one end of the circle all the way across. That would be your diameter. So if I don't really have diameter in my equation though, right? The equations that we were using up here, those were radius, right? So if I want to figure out my radius, it's just going to be half of my diameter. So right off the bat, let's just divide 13.6. Let's divide that by 2. So we can just go 13.6 divided by 2 is equal to 6.8. So 6.8 centimeters is my radius. That's what my r is, right? That's the distance from here to the end. I can even write that in here if I want now, 6.8. Okay, and then my slant height is 9.8 centimeters. So I'm going to let you guys go ahead and finish this problem for me. If you need to, look at the one above. It's exactly the same, just different numbers. So I'll let you guys go through that now. So yeah, answer that now. All right, moving on. Okay, and we are actually going to skip a few in example 6 here. So just go moving on. I'll actually let you guys skip 16 and 17, and we'll just move on to spheres. Okay, so in spheres here, really what we need here is just this formula. So surface area of a sphere, and off the bat, I guess, here, a sphere is like a ball. So when I say a sphere, that's what I'm talking about. It's a three-dimensional circle. It's a ball. It'd be, yeah. I don't know how to draw a ball on like a piece of paper, but that's what it would be. Okay, so that's the formula. Surface area is equal to 4 times pi times r squared. So you can look through this question if you want to. I'm going to jump into the next ones. So find the surface area of a sphere with a radius of 1.3 meters. So let's write down our formula here first. So the surface area is equal to 4 pi r squared. So far we only have one variable here, r, right? That's the only thing, and we have one number. So that's going to be as easy as just putting that number into this formula. So the area is going to be 4 times pi times 1.3 meters squared. And just to check that you're putting in your calculator properly, here's what I would do. I'd go 4 times pi. You should have a button that looks like pi on your calculator. Or you could just type in 3.14, doesn't matter. That now times 1.3 and then squared. And then that's not my answer because I haven't pushed enter yet. That's just what 1.3 squared is equal to. So I need to go that and then equals. Don't forget to push equals at the end. So my answer is 21.24 or 21.2. 21.2 meters and its surface area, so it's meters squared are my units. Okay, that's it. All right, I'm going to let you guys go ahead and do 19, just knowing that this time it gave us a diameter of something, right? So it's going to be really similar to the one above, but we need radius, right? How do you figure out radius again? So look back to our last video or the last questions I was doing. We did one similar where we figured out what the radius was compared to the diameter. Okay, so I'll let you guys go ahead and answer number 19 now. All right, 20. Find the surface area of a hemisphere with a radius of this. So a hemisphere, if I could draw it in 3 dimensions, is just half of a sphere. So if you took a sphere and cut it in 2, you'd end up with a hemisphere, right? You can also think of like the Earth is split up into hemispheres. There's the northern hemisphere and the southern hemisphere. It's like you're just cutting the Earth into 2 different parts. So if I want to figure out the surface area of, hint, half of a sphere, what would you do? You just divide by 2, right? That's all you need to do. So go ahead and answer this question, and then all you do at the end is just divide your answer by 2. So answer number 20 now. Okay, so now what we're getting into is nothing really new. We're just going to have to start to put these things together. So we're going to be able to figure out the area of these composite shapes. So moving on. Okay, so we're gonna have to try to figure out the surface area of shapes like this now. Where there's really 3 different shapes here, right? There's that one, and the cone on the end. What's gonna be helpful here though is to get the formula sheet out, and we can kind of break it up here. So you can see that in this question we've got a semicircle, or sorry, not semicircle, a semisphere. So we got surface of a sphere is going to be this, but just divided by 2, right? So that divided by 2. We've got a cone, is going to be just pi r squared plus the surface area of the lateral part. So we got to figure out the cone, and then we got to figure out the surface area of the cylinder, and then just kind of put it all together. So let's go ahead and go back to that. So let's write down. So let's figure out the surface area of the circle first, or the semicircle. So you go to your formula sheet. Let's just write down, or the semisphere, I should say. Let's write down surface area is equal to 4 pi r squared. That's what a sphere would be, right? So 4 pi r squared is what that area is going to be. But remember, that would be the surface area for like an entire sphere. If that sphere, like, you know, went all the way around, that's what it would be. So we're going to just divide our answer by 2. So if you want to even just go like divided by 2 now, or at the end when you finished it, that's fine too. So let's go, I'm just going to divide by 2 at the end. Let's go area of an entire sphere would be 4 times pi times the radius, though. This 0.8 is talking about the whole thing. That's the diameter. That's from there to there. We want half. The radius is half of that. So this is going to be 0.4 meters squared. So the area there is going to be 4 times pi times, actually, no, I don't need to write that again. Just go to your calculator, and we'll go 4 times pi times 0.4 squared, and then don't forget to push equals. So it's going to be 2.01 meters squared for my units. I'm going to put a box around that. Well, actually, no, I'm not going to put a box around it yet, because we also need to divide that by 2, right? So if I divided this by 2, so maybe like go divided by 2, your area for your semicircle, or half of a sphere, would just be, let's just call it 1 meters squared. I'm going to put a box around that because we're going to need it. Okay, now let's figure out the surface area of, erase that, of our middle section. So our middle section is going to be a cone, or sorry, a cylinder, but without the ends, right? Because we don't actually get the surface area on the ends part of it because they're on the inside of the shape. We just want the outside. So we just need that one part of the equation. So the whole equation for a cylinder is this one, right? Surface area is equal to 2 pi r squared plus 2 pi r h. So let's write that down. But then let's think about it for a second. This 2 pi r squared part of our equation, that was for the circles on the end, right? Pi r squared is the area of a circle. The 2 happens because there's 2 of them. So we don't need those at all because we're not taking the surface area of the inside of the shape. So we can just even ignore that. We can just take this part right out. So all we need to do is to figure this out is just going to be this part of the equation. Area is equal to 2 pi r h. So the area is equal to 2 pi. The radius, we already figured out it's going to be the same radius, right, from there to there. So that's going to be 0.4, same one as over there, right? Meters squared. And then the height of our thing is going to be this, the distance from one end to the other. So, oh, not squared, sorry. Hopefully you caught that. Not squared. And then times our height of 2.2 meters. Okay, so the area of our center is going to be 5.53 meters squared. Put a box around that because we're going to need it. And then lastly, let's do our cone. So our cone is also going to have the same radius, right? It's still going to be 0.4. So let's go and see if we can look up a cone and what the formula for the cone was. So surface area of a cone was this one, right? Pi r squared, that's the circle, plus pi rs. Okay, but now again, we kind of have a similar situation as the green part that we did there, is that we don't need the surface area of the circle on the inside because it's on the inside. It's not the surface area. So we don't need this. We don't need that circle part of it. So our formula is just area is equal to pi r s is the only one we care about. So let's do that. So area is equal to pi times my radius is 0.4, and the slant height, remember, was the distance from there to there. That's going to be 1.4 meters. So the area is going to be equal to 1.76 meters squared. Okay, now I just need to add all these things together. So finally, the total surface area here is going to be 1 meter, that's this one, right, squared, plus 5.53 meters squared, that's this one here, plus 1.76 meters squared, that one there, is equal to 8.3 meters squared. And then circle your answer. Okay, so that's it. So it's not really that much harder. It just takes a while to do, right? We got all those parts involved there now. Okay, let's move on. Okay, so now I'm going to let you guys skip a few here. Let's skip number 22. Can't take that one out. Let's take out number 23. And I'll kind of set you up for these questions. So number one, now these are just practicing everything we've kind of went through and learned. So it says, Bob is a metal worker and is making round cake pans. How much metal will he use in making a 9-inch round cake tin that is 1.5 inches tall? Okay, so for this one, just if you can't really see it, with this cake tin, we want to figure out the surface area of all of this, right? The tin all the way around the outside. We call the lateral surface area of a cylinder. But then we want to figure out the surface area of the circle on the bottom. There's a bottom to this cake tin too, right? So let's figure out the area on the bottom. So that would just be area is equal to, and remember for just a circle, pi r squared. If you want to look at your formula sheet, area of a circle, pi r squared. So that's where that would be, right? And then just fill it in. So we just want to make sure, though, that this 9 inches that we're using here, though, would you use 9 inches or would you use something else? So, yeah, so that's how you'd figure out the surface area of that, the bottom. And now if we want to figure out the surface area of the sides here, of this cylinder, look at the cylinder formula. So the cylinder formula, surface area of a cylinder, was 2 pi r squared. Well, that was the radius part, or the circle part of it, right? So we don't really need that one anymore. All we need is the lateral side lengths of it. So we need this part, 2 pi r. That's what that one is. So surface area is equal to 2 pi r. 2 pi r h. Sorry, I think was the other part of that, right? 2 pi r h. Okay, and that's pretty much it. Add the orange and the purple together in the end to get your total surface area, and then yeah, that's the answer. So I'll let you guys go ahead and answer number 1 now. Okay, number 2. How many square centimeters of paper are needed to produce 50 conical cups like the one below? Conical is another word for cone, so like cone-shaped cups. Well, we have a formula for cones. It's surface area of a cone right there, right? So pi r squared plus pi r s. So now just remember what the parts are for, though, right? This is a cup. Are we going to have a top on our cup? No, we want the water to be able to go into the cup. So there's not a top on it. So this part of our formula, that's the circle. That's the top part of it. Do we need that? All right, so that's your hint on that one. And then the next thing I want you not to forget is this. How much paper is needed to produce 50 conical cups? So that's step number 2. So once you figure this out, don't forget about the 50 conical cups part. All right, so go ahead and answer number 2 now. Number 3. Okay, how much corrugated steel will be needed to cover a Quonset hut, which is a kind of building that is just half a cylinder like this, that is 20 feet wide by 48 feet long if both the front and back are covered, except for a door that is 8 feet tall by 7 feet wide. So we've really just got the whole picture here. What we've really got going on is you've got a cylinder that's cut in two. Whenever you see that, we just want to divide it by 2. So what I would do is figure out what the total surface area of an entire cylinder is, and then divide it by 2. That would give you half of it, right? And then deal with your door afterward. So I'm going to go through this one with you guys too, but I want you to figure it out on your own first. So go ahead and answer this question now. Okay, so if the question didn't go very well, here is how you do it. So we're going to go get the formula for the surface area of a cylinder. So area is equal to 2 pi r squared plus the second part of it is 2 pi r h. All right, so that would be for an entire cylinder, right? And then I'm just going to divide that by 2 when I'm done to get half of it for this Quonset. Okay, area is equal to 2 pi r. What is r? Well, r is going to be half. This is the diameter, right? That 20. So half of that is just 10. So this is going to be 10 squared. And then that plus 2 pi. This is going to be 10 again. And then the height in this case is going to be 48. So we got area is equal to 2 times pi times, actually I'm just going to put the number in. Okay, so this part of it is 628.3 meters, feet squared. And then plus, and then this part would be, I'll put in here, 2 pi, here, 2 times pi, I should put in this one, I think I didn't realize that. Okay, so let's go 2 times pi times 10 times 48. So 3,015.9 feet squared. Okay, and if I added those two together, so we got that. I'm just going to keep my number that I had in there already and then just go plus, and then the 628.3. So 3,644.2. It said it and I forget already. 6,000 or 3,644.2. Those are supposed to be 4s. All right, so that's the surface area of an entire cylinder, right? We want half of that because we cut it in half. So I'm just going to go with that. If you wanted to, let's just go divided by 2. Okay, so I've still got my calculator, the number going on there. So I'm just going to go with that. And if I go divided by, this keeps the number, 2 is 1,822. .1 feet squared. Okay, so that's what I got so far. Now there's just this door to figure out. So I got the surface area of like everything right now. I just need to subtract out the door. So the door, I can figure out the surface area of this thing pretty easily, right? The surface area of a square is just base times height. So the area of that thing is just going to be 8 times 7. So the area of that door is 56 feet squared. So if I subtract that out, what I'm going to have in the end is 18,022.1 feet squared minus 56 feet squared is going to be equal to, and I've still got my calculator, so I'm going to just go minus 56. So that's going to be 1,766. .1. Sure. Feet squared. And then I'll circle my answer. Okay. So hopefully that went okay. Let's move on to number 4. Okay, just to give you guys a bit of a break, let's take number 4 off. We're going to cut that one out. Number 5. This one's pretty straightforward. I'm not going to give you any kind of hints. I think you're on your own now. Calculate the surface area of a cone that has a radius of 12 feet and a slant height of 15 feet. So go ahead and answer number 5 now. Number 6, again, I think is pretty straightforward. Just make sure you get it right on your formula sheet. So this guy. A tennis ball has a diameter of 6.7 centimeters. What's its surface area? So go ahead and answer number 6 now. All right, that's it for 3.2. So we'll start 3.3 in the next video. Yeah, so I'll see you guys in the next one.